My name is Keith Kruger. I'm a game developer, a software consultant, and a teacher, and I've made this tutorial just for you. Welcome to Common Concepts using ambient sound to enhance immersion. In this tutorial, we'll look at what ambient sound is, how attenuation and fall-off works, and how positional audio helps to immerse the player in your game universe. What is ambient sound? Ambient sound is the background sound in any given environment. There's almost no environment that exists without it, but there have been rooms built to eliminate it, known as anechoic, I can't pronounce it, chambers. And spending too much time in one of those can actually drive a person crazy. Even 45 minutes of time without any background noise where they're just hearing like their own heartbeat and all that is too long for people to handle. We often learn to tune out ambient sounds, but as they are so important for immersion, let's take a moment and engage in a listening exercise. I'm going to cut the soundtrack from this recording for 30 seconds. During that time, close your eyes and just listen to the world around you. See how many sounds you can identify. Did you listen well? Let's take a moment and identify ambient sounds. There are sounds that are always going, and there are sounds that happen at one time or in a random, inconsistent fashion. As I sit here with my air conditioner turned off, what do I hear? I hear other air conditioners in my apartment building. I can hear the electrical hum from my kitchen appliances. I can hear the water streaming and water pump noise of my cat's water dish. And those sounds are always going. But in addition to that, I hear the occasional sound of my blinds hitting each other due to the slight breeze. I heard my refrigerator cycle on briefly, and I heard a bird outside. Those weren't continuous, but they're still part of the ambient sound environment. They're not being triggered by an action that you're doing. They're just there, and they help flesh out the real world. Finally, all of these sounds have a position. While some of the sounds may feel like they're coming from everywhere, such as the sound of rain during a storm, your day-to-day ambient sounds all have position in relation to you as a listener. So when you're building your game, you not only want to have ambient sound, you want to have ambient sound that has position so it feels immersive. Let's look at how this is done in Unreal Engine. So what I've done for this tutorial is I've created a new first-person project and left it mostly as it was initially generated. I did this using Unreal Engine version 4.12, and because this tutorial is focused on sound, I'm not really going to do much to change the environment. Visually, I've added a couple of things to help denote where sound sources are, which we'll talk about as we add those sounds, but nothing else has really been changed. So the goal here is for you to, when all is said and done, be able to close your eyes and feel as though you're in a natural environment. For me, this works better using my surround headphones because I don't actually have a surround sound speaker set up for my desk. It may be different for you, but the idea is to be able to hear positional audio. So first off, let's take a second and talk about what a non-position sound is. So as you're looking around your screen, your view, I'm going to back up a little bit. As you're looking around, you can have things that are sound sources over here. You could have something on a table over here. You could have a window over here. You could have something over here, and sound would be coming from those positions. But sometimes you just have a need to have a sound that covers everything, and you don't need it to come from a particular spot. That's going to be a non-positioned sound. And the reason why you might choose to use a non-positioned sound for your ambiance rather than having a whole bunch of positional sounds would be, things like you need to conserve your costs. You can't afford a bunch of different audio files for it. You just want to conserve space. You don't want to have as many actors running, a number of reasons for it. And it's not as immersive as positional audio because it's not going to trick your ear into thinking you're in a particular spot, but it still helps with the immersion. So what we're going to do here is we're going to actually use a looping soundtrack inside of an ambient sound actor. And you can get your ambient sound actor, let me clear this back out, just by searching for it. And it'll come up as ambient sound, and then you can put it into place. And we're going to put our first one in this spot that I've put a little bump for in a note, non-positional ambient sound. And really, it wouldn't matter where we put this in here, just to put it in here somewhere, because again, this doesn't have position when we're done. So let's drag that out. I'm just going to pull it up so we can see it here better. So, as you can see, it's on screen. It's a speaker icon with a check mark. Pretty much all the sound cue things are speakers if you put them on scene. So let's look at the detail you're going to have. First, you'll see the sound section. In this section, you're going to choose your sound wave to use. Of course, you have additional options like is UI sound, which means is it going to play while the UI is present, like when the game is paused. Can you override other sounds? If you're going to change the volume, if you're going to change the pitch, things like that. And we're not going to cover all these because, again, this is the common stuff, the easiest stuff you're going to get into. And then you can test your sound using play and stop buttons. Below that, you get the attenuation settings. And the attenuation controls manage the shape and size of the area in which the sound can be heard. So you can either override the attenuation when you create your ambient sound actor, or if it's attenuation, if it's a sound field, if it's a sound shape you're going to use over and over again, you can just create it as a separate setting, and then you can reuse it. After that, you've got the modulation section, so that's just going to let you modulate the pitch or volume, and if you set these as different ranges, it'll randomly move between the minimum and maximums. Another setting you might need is sound concurrency, and that's not one we're going to touch on in this video, and it really just helps you understand what happens when you are playing this sound and there are other sounds playing. So it could take priority and stop other sounds, it could wait until other sounds are done, and when I do the quote master class for sound, I will get into this more, but for this Common Concepts video, we're not going to talk too much about that. So for our scene here, what we're going to do is we're going to pretend, because again, I'm not changing everything, so we have to pretend that we're indoors on a rainy day. And our non-positional sound, the first one we use is going to be a hum, kind of like an air conditioner. And so I've already imported a few sound packs from the marketplace. And the one we're going to use for this first sound is a sci-fi hum, which is on a loop from the Universal Sound Effects package. So, okay. So what we're going to do is we're going to go back up here and we're going to create a new blank sound cue. And you can see that that opens up this nice window with an output. And you're going to find that this is very straightforward. There are a lot of settings here. I encourage you to go to the Unreal docs under sound system and look at what these different things are for building out a sound cue. The most basic thing is simply to hook a wave player up to the output. So let's do that to start. So we have our wave player, we're going to grab a sound, and that sound is going to be sci-fi hum in my case. And then you can play it and you can see what it sounds like. We of course want to click looping because this is going to play over and over. And so it's a pretty straightforward sound. So now, if we go into the actual game, and we go ahead and we play, what you're going to get is you're going to get the sound all around. It doesn't matter where you go here, you're still going to hear it equally from all directions, because it doesn't have any position assigned to it. It has no attenuation to define any restricted shape. but it's a little loud. So let's go in and let's actually modulate it down a little bit. So let's drag out a modulator, which will connect up. And then the modulator again, much like the modulation settings here, or the multiplier settings here, where'd modulation go? Modulation here, it just provides minimum and maximum ranges for the pitch and the volume. Now I don't actually want the pitch to change at all, so I'm going to set both those back to 1. For the volume in, we're going to go with 0.1 for now for both of these, because I don't want that volume varying either. We're just going to go back and save, and then we'll play it again. And it's definitely quieter. When we start adding in other sounds, we might want to make adjustments. And again, all I can say is note that as I move around, the audio stays the same volume from all directions. So we've got that going. We have the nice hum. You could think of that like as a radiator or something else going all the time. But let's add another non-positional ambient sound. And we don't have to actually drag in another ambient sound actor to do this. We're going to add some rain to make it sound like a rainy day. And rain is falling on our roof, so no matter where we are in the house, we're hearing that rain on the roof. As I said, we don't actually have to drag in a new ambient sound actor. You could, but it's actually easier if you're not going to reuse things like attenuation and such, to just go back and edit your sound cue. What you're going to do is you're going to pull in another wave player because you're playing a different wave. So with this one, we're going to find rain 01. So that's our rain. And you might want to try and hook this up straight, but that would then stop this from working. So what you want is a mixer. You're going to pull out a mixer, and the mixer can have multiple inputs. You can keep adding inputs, but we only want the 2. So we will set this up and plug it into one, and we can plug the rain into the other, and then we can plug the output up to the mixer. And now if you were to play this, and the reason why I keep switching over to the game to do it is this can work, obviously, because you can play that and it'll work, but it picks up the sound better for recording if I do it through the actual game. So now you can hear the hum is still in there. The rain is pretty loud, again, all over the place. And I forgot to do something with the rain, so the rain stopped. Let's go back to our sound cue. So the rain is a loop, so we have to click it for looping. It's still loud. I think I actually want to adjust the volumes of these again. So we will grab another modulator and pull out here. We'll hook that up. And again, I don't really want to change the pitch, but I do want to change the volume. So let's take this down to 0.2 maybe. And I actually want to change that modulator, and I'm going to make it 0.05 instead. So I just want it to be, a nice little noise that in real life you would tune out. You wouldn't pay much attention to it. Let's save that. That's better. I still think the rain can actually come down a little more. So we can do that. If we want to do everything in proportion now, because we've got those in our sound cues, we can actually adjust our volume multiplier here. So if we went like that and played it again, it's actually adjusting it. So we'll leave that for the moment. We have a nice bit of non-positional sound that's running throughout our house, the rain and the hum. And next, let's add a positional ambient sound. So let's say something like an alarm clock. So let's add our alarm clock. What I've done to fake an alarm clock is I've actually created a little circle on the wall and labeled it clock. And we're going to go ahead and drag in an ambient sound actor just like we did before. So we'll pull that in. I'm going to pull it out a little bit so we can actually see it. And this time we're going to make use of attenuation. So first things first, let's assign our sound cue to it. And I don't actually have a ticking clock in any of the packages that I have currently, but I have a ticking clock in an external, non-marketplace, non-game related sound effects CD pack that I have, and we're going to use that. It's not perfect. It's got a weird little repeat to it when you start looping it, but for the sake of the demo, it's going to work for us. And what I've actually done is I have imported that. And so it's an imported sounds. And when I imported it, I went ahead and clicked looping on it. That's the only thing I changed. I left the rest the way they were. Close that sound cue for now. And we are just going to go ahead and pull it in. So let's grab that. Now you could make a new sound cue for it. In this case, the attenuation is going to handle the volume adjustments and such that we need. So we're just going to do that, and I need the clock ticking sound wave. So again, if we were to play right now, it's very loud. It's louder than the rain, louder than everything else, and it's non-positional. But we actually want to give a position. I'm going to zoom up here for a second. And so what you're going to do is you're going to adjust the attenuation. And as I said earlier, the attenuation is the shape. It's the sound shape that it goes into. And what it's going to do is alter the sound so that it becomes softer and then vanishes as we get further away. So attenuation defines the volumetric space that a sound exists within. Let's take a look at that for a second. So if you look at these graphics, these are the different attenuation shapes. The closer you are to the center of the space, the louder the sound is, and the volume falls off as you move to the outer edge of it. So you have 4 different shapes involved here. You have a default sphere, you have a box, you have a capsule, and you have a cone shape. Each provides different sound dynamics for how that fall-off occurs, and most often you're going to stick with the default sphere. But other shapes can come in handy. If you want to keep your shape of your sound within a particular room, a squared off room or a rectangular room or whatever, you will want to use a box shape most likely. Let's say you were having sound coming out of a deep crack or hole in a cave wall. You might use the cone then to affect the shape of the sound and how it works. So let's jump back to one really quick and add an effect to our alarm clock. Okay, so we're back in here. Let's take our ambient sound actor, which we have selected. Let's override the attenuation because we aren't going to be doing a reusable one right now. Now we're going to attenuate, and we want spatialize, so it's going to be positioned in 3D space. Then here are different ones you can do. You can see we started off with the sphere. Whoops, wrong one. Sphere. You can do the capsule shape. And all these are very, very large at the moment. So if we were to shrink this down, you'd be able to see the shape there. Same for a box and a cone. I need to make that cone a little bit different here because the angle and offsets and all that are much different. But let's go back to our basic sphere, and we're just going to use that for now. And the radius internally, we'll just leave it 150. So that's the loudest part where the volume is at full tilt. And then we'll have a fall off distance, and we'll say 700. And so as you're moving away, it will get increasingly less loud. So if we save that now, and we play it, where I'm standing now, I can hear the rain, I can hear the hum like you would expect, but I don't hear the clock. If I start moving closer to it, you'll hear it, and it's getting louder and louder as I get closer to it. As I move away, it gets softer until it's gone. So that is an example of positional sound. It makes a big difference in how sound works in your space and how much immersion you get, because as you move around, you should be able to hear things much like you would in real life, based upon position and such. Now we're going to add some more positional sounds here, but at the moment let's do one other thing. Let's go ahead and let's tighten up this radius even more, so it's only really loud if you're right on top of it. And let's change this to a different type of attenuation, where it calculates the distance for the sounds. Let's play that again. So again, we're far back, we don't hear it. And then the fall off is slightly different. So we have that. Now let's add one more ambient sound, which is going to be coming from our window. So I've faked a window over here. And what we're going to do is we are going to show how you can set up one-off random sounds. So what we've done so far are continuous looping sounds, which are good for obviously noise that are constantly happening. But you'll have other ambient sounds that are more random, that don't necessarily follow a pattern. They just add to the ambiance because they're things you would hear in real life at random intervals. So we're going to add a pigeon cooing, because I have sound effects for that, and we're going to add some crickets. So first, let's add the pigeon sound, and what we're going to do is drag our ambient sound actor out again, and he's all set. We are going to go ahead and make a new random loop with delay, and I'll tell you why we do that in a moment. Let's pull that up. So what this does is it allows us to combine multiple waves, and it chooses one at random. That's what this random thing does, and it will play them based upon a delay, so every X amount of time, and looping will of course call the whole thing over again. So let's make enough room here to be able to hear all of our different sound things. We're going to add a few different ones, so we can click that. Let's drag out some more wave players. We'll hook those up. And again, depending upon the way you're handling your sound, for instance, this is going to be coming in from an outside window, you can actually tie multiple things into one sound cue, which we'll come back to when we add the crickets. So let's go through here and let's find our pigeon sounds. Okay, so there's one long call, and a different long call, and then we'll grab a bunch of short ones. These are all mono, so position will be great, but you know they're not going to be real well-rounded stereo type sounds. Add another short one, and finally let's say 3, we'll grab 4. So we've got 4 different sounds here. We're just going to leave all the individual settings as they are because we'll adjust those elsewhere. So choose at random. You can apply weighting. So if you want something to happen more often than another, you can say 1.5, and therefore that particular sound is more likely to happen. In delay, you can say where your delay minimum maximum is. So we're going to say for these birds that they will go anywhere between a second and 10 seconds. And then, of course, it loops. So if we go back here and we play, and I haven't actually done any attenuation to put a shape on here yet. So you can see that it's picking out different sounds, different times. which again makes it feel more natural because there's not a set pattern that people are going to pick up on. Now let's go ahead and let's change the attenuation. And again, instead of making an attenuation settings component, we're just going to override it. Leave all that the same. We will stick with the sphere, but we're going to make this much bigger because we're going to say the birds are pretty loud. So there's our loudest one maybe. And then our fall off, let's make that 1600. Okay. So we'll save that. And we will play. You can kind of hear that trail off as I was going backwards. Okay. So, we now have the random pigeons going. We have an alarm clock that is ticking if we get close enough to it, and we have our rain on the roof and the hum of our appliances. Now let's go ahead and add our crickets for fun, and we'll see how that affects things. So again, you can go back into your existing sound shape. You don't have to make a new one, and all you will actually do is duplicate some of this. Pull it all down there. And then you're going to add a mixer because again you're mixing more than one thing. So this way we get a mix of our two different sounds. We'll go ahead and change the delay on this first. The crickets will happen more often. The crickets can happen, you know, about every half a second to every 3 seconds versus the pigeons, which are every 1 second to every 10 seconds. We can go in here and change this. So we've got multiple cricket noises. We'll just go down through and choose them. 2, 3, 4, and 5. And then we'll change our random quick just to remove our weighting because I don't see any reason to keep the weighting on there. And now if we go ahead and go back and we save and play, you can hear both the crickets and the pigeons. And again, it gets softer as I get near the end of the fall off sound. So now let's go to one spot. If you stand in one spot where all the sounds are available, and you just slowly turn the mouse, you're going to hear the spatialization of all the sounds. So as you turn, as you would expect, sounds will get louder as they move between, which ear is closer. The overall sound keeps going. And that helps you feel more immersed in the environment. So close your eyes and just listen and move the mouse around a little bit, maybe move around and see how you move in and out of sound fields. The fall off for the alarm clock might be a little sharp, so you might want to extend the fall out further, or change the calculation for it, the distance algorithm. You can change other things for like applying low pass filters and such. And I encourage you to play with all those. Again, I encourage you to go out to the Unreal Engine documentation and see what you can turn up. So that's it. You now have an understanding of how the basics of ambient sound work. Mind you, in your real game, you're going to want to spend a lot more time planning out your soundscape to ensure that it matches up with your environment. So let's say that, this was a house environment, and this window did exist, and outside was a pond. And so we had crickets and our birds and a pond out there and such. You might have the ambient rain that goes through the whole house, but then you might have a different type of looping ambient rain sound that's coming from where the water, where the raindrops are hitting the water, and that would be coming from outside and would trail off as you got further away from the window, because it's more distinct with the window being open. And you want to think about things like that. You know, if you have different types of structures, let's say you have a garage and you have a car parked outside of the garage, you know, you'll want to have different noises related to that. So again, the rain falling on the car might have a different sound than all the other rain, and you want to make adjustments for that. So, you know, just think about those things. Again, in this particular case, if I were building this and I didn't intend my characters to ever actually go outside, I might not use a sphere for my ambient noise. I might actually use a box internally. Or if I had them going outside, I might make it more of a box with a cone or something, so that the sound is coming mostly through the window if you're indoors, but still has the wide range outdoors. Just the point is, being conscious of how your soundscape works is going to go a long way to building immersion for your game. So with that said, you know, go play with sound and make your games even better, because you now have a way to start, and I know you can do it. In this episode, I'll be laying out the goals and expectations for this series, which is a larger and more expansive effort than anything I've tried previously. I'll review the high-level stages of game development that will be covered. And the upper arm twist for that side is the right arm. We have to go into the legs, of course. So